Hi teens, it's me, your teacher, Mr. Peacock, still here to teach you. Now, if you are in my class today, because it's a B day and I'm not here, if you would please note you are supposed to be using your new packets. Those packets are at the front of the room if you have not yet gotten one. I can wait. Now, while we're waiting, if you're watching this online, I put a link to the notes for this lesson in the show notes. All right, hopefully everyone's getting one. Do 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 do. All right, and we're done. So today we're actually going to start a whole new unit. And the first lesson in that unit is parabolas, because it's something that theoretically you've seen before, but it's going to teach us a couple terms that we're hopefully going to use a few more times during this lesson. So, parabolas. Hey, we've done these before. I'm sure that means this will be wait. A parabola is the set of all points on a plane that are the same distance from a fixed line, the directrix, and a fixed point not on the line, the focus. So you might be going, I don't know those words. These are new words. This is not the definition I know for parabolas. Don't do this to me. Either way, we have to do it. So if you would, please, I can help you figure out what these are, though. If you look directly underneath that little part of your notes, you're going to see this. Standard form with center of HK. Ooh, do you see the word center there? I don't like it. That word is bad. So what we're going to do is I want you to X out that word and write vertex with vertex of HK. So we have two different forms of this that we have. We have our horizontal and we have our vertical. So with our horizontal, you will notice that we have a directrix with each form, and they are both vertical lines. Those are, if you look on the one that opens to the right, it will be towards its left. If you look at the one that opens towards the left, it is on the right. Then we also have the focus, which you can see is green. If it opens to the right, it also happens to be the focus is to the right of that parabola. If it opens to the left, the focus is to the left. So it works how you would expect. It kind of looks almost as though the parabola is trying to eat the focus. Now, we actually have a formula here for this, and that is plus or minus 4p x minus h equals y to minus k squared. By the way, plus means opens to the right. Negative means opens to the left. Now let's talk about vertical. With vertical lines, you can see that we have a directrix on each. Whenever it opens up, the directrix is below. Whenever it opens down, it's above. Then we also have a focus, and just like last time, it appears that the parabola is eating it. So if the focus is above, it opens up. If the focus is below, it opens down. And here's our formula now. 4p times y minus k equals x minus h squared. Now, if it is positive, that means it opens up. If it's negative, it opens down. There we go. So positive, negative, and over here, positive, negative. All right, so now what we're going to do is we're going to try out a few things with this. We're going to start with sketching a graph, then writing the equation for a graph that is the set of all points in the plane that are equidistant from a given point. By the way, that means that literally at any point, if I was to find the distance from that point to the focus, or just go straight down, left, right, or up to the directrix, it would be the same distance. So what we're going to start with is this equation right here. Well, I mean these points. So our first thing that we need to note is the focus. The focus is at 0, 2. Right there. And our directrix is at -2. So the first thing we actually need to find is what I like to call the vertex. You know what the vertex is, and I'm just going to say, if you look at the focus, in this case because the focus is above, if you find the exact midpoint between that focus and just straight down to the directrix, that is going to be our vertex. So our vertex in this case is at the origin 0, 0. Now, the next thing that we need to do for our formula is you might notice that there was a letter P. By the way, remember, vertex is H, comma, K. There was a letter P. Now, you might notice that you actually have a P on, well, actually, no, it's not on your notes, but the P is the distance from P. That is the distance from focus to vertex. And because it's distance, it's always technically positive. So the distance in this case from the focus to the vertex is 1, 2. So in this case, I could say the P value was 2. Then I just plug in my values. So this formula is the one that we just wrote. Because it's going up, it's a positive 4. So I would write 4 times, in this case my p-value of 2, times y minus my k value, which was 0, equals x minus my h value, which was also 0, squared. So it becomes 8 y equals x squared, and I personally would go y equals x squared over 8. And that would be my equation. So let's actually draw that up. And that would be our equation. All right, let's try another one. The focus in this case is at -3. So at -3, we have our focus. And at +3, at x equals 3, being a vertical line, we have our directrix, which tells me it's going to be opening up horizontally. Now, the midpoint between those two, let's see, the full distance is 6, so it's going to be 3 apart from each one, meaning our vertex is once again at 0, 0. And our p-value is half of that 6, or 3. So let's see. That means, in this case, because it's going to open up left, I would say -4 times our p-value of 3 times x minus our h value of 0 equals y minus our k value of 0 squared. So that becomes -12. X equals y squared. You could also write it as x equals y squared over 12. Both of those are accurate. Okay, so now what we're going to do is we are going to sketch the graph. Then we are going to write the equation of the parabola with the given information and a vertex and the origin. So in this case, our vertex is at the origin. That's very important. That means our vertex is at 0, 0. So here we go, first point. Now this is going to be at -5, so 1, 2, 3, 4, 5. There's -5, 0, because it's x equals. So that also, by the way, means, even though it doesn't ask for it, our directrix would be at +5. Now I already know our origin's at 0, so it doesn't really matter about that part. But so that would be our look of our thing. Now we need to put in some values. Our p-value, once again, is 5. So what we would say is we would say -4 times 5 times x minus 0 equals y minus 0 squared. So negative 20x equals y squared, or x equals y squared over negative 20. Now here's our next one. The directrix is at y equals negative 2. So in this case, negative 2. You know, I feel like we've already done this one, but I already know our origin's at 0, meaning our p-value is still going to be 2. Our focus, by the way, would be 0, positive 2. And this would be what our equation would look like. And to be fair, we've already done this one. It was 4 times 2 times x minus 0. Sorry, not x minus 0. It was y minus 0 because it's going up and down equals x minus 0 squared, or 8y equals x squared, or y equals x squared over 8. So now what we're going to do is we're going to do another thing. This time we are going to be sketching a graph, and then we are going to identify the vertex, focus, and directrix of each parabola. So we're doing the things that I've been doing anyway, but this time we're doing it from the stuff. So it's actually sometimes easier to identify the vertex, focus, and directrix than to do that. So I'm actually going to do that. So I'm going to say x squared equals negative 16y. So the first thing I know is, in this case, because it's y equals an x squared, it's going to be going up or down. Because it's negative, it is going to be something that looks like that. I don't know exactly what it's going to look like, though, so I'm not declaring it yet. Now, some things I know. This is the same as negative 4 times p times y minus k equals x minus h squared. So let's start with this. Negative 16 equals negative 4p. That means that p equals 4. Now, let's talk about the next part. The next thing I note is y minus k equals y, which means k has to equal 0. And finally, x minus h equals x, which means h has to equal 0 as well. So that means our vertex is at 0, 0. Because it is opening downward, our focus is going to be at 0, negative 4. And our directrix would be the other direction at y equals 4. And our sketch, to make it just a little bigger, would end up being like this. And there we go. All right, let's try another one. This one says 2x equals y squared. So because y is the one being squared, that means it's going to open up left or right because that's positive. I know it's going to be something opening right. So now that I know that, what I'm going to do is I'm going to plug this in. So in this case, notice once again, x and y have no numbers next to them. I just know that that means my vertex is going to be 0, 0. Now, 4p is equal to 2. That means p equals 2/4 or 1/2. That means, let's see, our focus is going to be at 1/2 0 because it's going to be moving to the right. And then our directrix is going to be at x equals negative 1/2. And our final graph would look something like this. And there we go. Okay, here's our next one. This one says 16 times y minus 3, x minus 2. So let's start with our vertex. Remember, our vertex is going to be x minus 2 is equal to x minus h. So that means h is going to be at positive 2, and k is going to be at positive 3, because it's y minus k. Now, next thing that I'm going to notice, so that is our vertex. The next thing I'm noticing is the part being squared is x, meaning it's going to be something facing upward, something like that. Now, let's talk about the other parts. So, in this case, 4p equals 16. That means p is 4. So if this point is originally at 2, 3, if I want to find, if our point is originally at 2, 3, then our focus is going to be for higher at 2, 7. The focus is at 2, 7. Now, in order to figure out our directrix, I have to instead go down 4. So 1, 2, 3, 4. Meaning our directrix is at y equals negative 1. Now let's try one more. Okay, so in this time, notice it says y equals, y is the one squared, meaning it's going to be moving left or right instead. So first thing we need to do is figure out our vertex. Our vertex is going to be x plus 4, so negative 4, and y plus 2, so negative 2. So there it is, and if you look, because it's going to be negative 20, that means it's going to actually open towards the left. Now in this case, negative 20 equals negative 4p. So I would divide by 4, meaning p is 5. So our focus in this case, because of the fact that we're moving left to right, is going to be, let's see, we're at negative 4, we're moving 5 to the left, that would be negative 9. Let's see if I can write a 9 better than that. Negative 9, negative 2, because it didn't move up or down. And our directrix is going to be 5 to the right, which means x equals negative 4 plus 5 is positive 1. Okay, so now what we're going to do is we are going to rewrite the parabola equation in standard form by completing the square. Then we are going to find the vertex. Now, we haven't completed the square in the while, but we did do it in an earlier lesson. But we are going to rewrite the parabola equation in standard form by completing the square, then find the vertex. So what we have to do first is we have to get the variable that is being squared all by itself. So do you see how x squared is the one that's being squared, so x? Now when I say all by itself, I mean all the x's on one side, all the y's and other numbers on the other. So that means that we are going to have to subtract 3y and subtract 12 from both sides. So that ends up being x squared plus 6x equals negative 3y minus 12. Now let's talk about completing the square. So for completing the square, the idea is that I want this to end up becoming x plus whatever half of 6 is. So the way that that works is we have x squared, we have 6x, and then we have plus whatever that is squared. So it has to be something where I add them together. What two numbers that are the same added together are 6? So I do 6 divided by 2. So I do 6 divided by 2 is 3. So that becomes plus 3 squared. So that ends up being x squared plus 6x plus 9. Now, if you're wondering why, it's because I would then say, what numbers multiply to be 9 and add up to be 6? We'd say 3 and 3. And then you would go, oh, wait, x plus 3 squared. So, anyway, though, we're saying plus 9. So, x squared plus 6x plus 9 equals negative 3y minus 12. But if I add 9 to one side, I have to add it to the other, plus 9. So our new equation, and the one that we're going to be using for this part, is, we've already said this is x plus 3 squared equals negative 3y minus, in this case, negative 12 plus 9 is negative 3. Now, is there anything I can do to the y side? And the fact is that there is. I can go and pull out a greatest common factor. So this becomes x plus 3 squared equals negative 3 times y minus 1. So now that we've rewritten this in standard form by completing the square, I can say that our vertex would end up being, let's see, x plus 3 means that our vertex would be at negative 3, and y minus 1 means our y value would be positive 1. And that would be our vertex right there. Okay, so now let's try this one. Now, in this case, you might notice that y is the thing being squared. So I need all my y's on one side and everything else on the other. So y squared minus 4y minus 2x plus 10 equals 0. That way I can just go plus 2x minus 10. So y squared minus 4y equals 2x minus 10. Now I have to complete the square. So I go y squared minus 4y. So I need two numbers that add up to be negative 4 that are the same. So that would be negative 2 and negative 2. So it becomes plus negative 2 squared. So plus 4. That means I add 4 to both sides. Y squared minus 4y plus 4 becomes y minus 2 squared. And this becomes 2x minus 6. Our new equation in this case is y minus 2 squared equals, our greatest common factor is 2 times x minus 3. This is our equation, which means our vertex would be 3, 2. All right, so this section says to solve each system of equations by graphing. So what I'm going to do is I'm just going to find some points if I'm going to graph. So I'm going to start with our first equation right here, x and y. Now I'm actually going to start at 0 because at 0 it's just going to be 8. I know that much. So if I go to 1, negative 1 squared is just negative 1 plus 2. Negative 1 plus 2 is going to end up being, that is negative 1 plus 2 is going to end up being 1 plus 8 is 9. 2, let's see, negative 4 plus 4 is 0. 8. Ooh, I think we found our vertex. So this is our vertex right here. Good, we have a vertex. So now I'm just going to do 3. So that's negative 9 plus 6 is 3 plus 8. So wait, negative 9 plus 6 is negative 3 plus 8 is 5, which means at negative 1 we would also have 5. So now let's do a couple more. 4, let's see, negative 16 plus 8. So at negative 16 plus 8, oh, that ends up being 0. So negative 2 is 0. And just one more, 5. Negative 25 plus 10 is negative 15. Plus 8 is negative 7. So negative 3 is also negative 7. Now that we've had those, let's plug in these values just to figure it out. X, Y, oh wait, I should graph those. Negative 3, negative 7, negative 2, 0, 1, 5, 8, 9, 8, 5, 0, negative 7. I don't need to try quite as hard. I just am going to say at 0 it's 2. So plug that in. And then rise over 1, up 3, up 3. So there's our first side. This is our first equation that works together. And that was at 2, 8. Now let's go down 1 over 3. Down 1 over, down 3 over 1 I mean. Down 3 over 1. There's our second one at negative 3. Negative 7. So those are our two values. Negative 3, negative 7, and 2, 8. Okay, so we're going to solve each of these systems by graphing. I'm going to start with this one. Now, I'm going to start with, once again, 0, x, y. So at 0, let's see, we get 2. At 1, that ends up being 1 minus 3 is negative 2 plus 2 is 0. At 2, we also get, let's see, 4 minus 6 is negative 2 plus 2 is also 0. Oh, look, that means our vertex is going to be around 1.5. But now let's keep going. Negative 1, that becomes 1 minus 3, no, minus 3 times negative 1, so 1 plus 3 is 4, plus 2 ends up being 6. And then at negative 2, 4 plus 6 plus 2 is 12. Negative 3, 9. Plus 9 is 18, plus 2 is 20. So, let's see, 3 is going to end up being 2, 4 is going to end up being 6, 5, 12, and that's probably enough. So, let's see. 2, 2, 6, 6, and a little bit too high. Now let's deal with our other one. Negative 2x plus 5. I know that at 0, it's 5. Then I go down 2 over 1, down 2 over 1, down 2 over 1, up to, all right. So here's our second graph. Now in this case, these are inequalities, so let's see. This has to be less than or equal to, so, and the other one has to be greater than, so just in the center, meaning the only area that is fully together is this area right here. Meaning this is our answer, that little area right there. All right, so now what we're going to do is solve each of these systems, well, in this case, one system, by substitution. Now, substitution is a much easier option because I can just substitute this for y. So 3x plus 2 equals negative x plus 2x plus 8. Negative x squared plus 2x plus 8. So I'm actually going to move everything over to the side with the 3x. So add x squared, subtract 2x, so plus x, and then subtract 8, so minus 6. X squared plus x minus 6 is 0. So I just need to figure out what are two numbers that multiply to be 6 and have a difference of 1. So one's going to be positive, one's going to be negative, so 3 and 2. The positive one is larger, so 3 and negative 2. So x plus 3, x minus 2. That means x is going to either equal negative 3 or positive 2. To find our two answers, we plug those in. So I'm just going to plug them into the bottom equation. That's easier. Negative 3 times 3 ends up being negative 9 plus 2 is negative 7. Then 2 times 3 is 6 plus 2. 2 times 3 is 6 plus 2 is 8. Those were our two answers. And if you look right above, you will see those are the same answers we got earlier. So there you go. That is it for the lesson. Thank you for watching. If you are in class, this is not the end of class. I've counted it. There's still time left. So if you would please, the next page, you will see your homework. Please work on your homework rather than having to do it later. Please work on it in class. Please be respectful of the sub and have a good day. If you're watching it at home, if you're in my class, you should still work on your homework. Thank you. Goodbye.